Pre-Calculus. This first lesson in 5.3 is going to cover some of our more basic trig equations that we're going to solve. We're going to start off by looking at these helpful hints. All right, to verify means that you will show that a solution works in an equation. You may substitute and simplify, or actually go through and solve the equation. I'm going to, on this one, in this lesson, I'll show you how to use substitution to verify. In this lesson, we'll also solve equations, but in today's examples, we're just going to be finding the solutions in an interval. As we progress through the lesson, so over the next couple days, we'll be working on solving the equations. So when the directions say solve, we're going to find all solutions, which include all rotations. But again, today we're going to focus on this part right here. We're going to be looking at just one interval, one time around your unit circle. Before we get started with example 1, I want you guys to go ahead and get out your unit circle. So having a picture out of your unit circle is going to be super helpful. All right, example 1, first we're going to just verify. So the directions say verify. I'm just plugging in pi over 6 for x. And I'm showing that, hey, when I plug in pi over 6, I actually get 0 back for an answer. So we're going to take the cosecant of pi over 6, and that fourth power means we're going to take the result to the fourth power. And here we're going to just square the cosecant of pi over 6. And we want to verify that this does equal 0. All right, so we know the sine of pi over 6 is 1/2, so the cosecant would be 2. And so we have 16 minus 4 times 4, and so 16 minus 16 is that 0 we were looking for. All right, on this one we're going to verify that pi over 12 is a solution to this equation. So again, the directions say to verify. So here's the answer. I'm just going to plug it right in right here. And I'm going to square that. And I want to show that that result does come out to 0 as well. All right, the tangent of, or the 2 times pi over 12 is pi over 6. The tangent of that is the square root of 3 over 3, or if I don't simplify it, it's 1 over radical 3. Squaring a radical removes it, so we have 1 minus 1, which is that 0 we were looking for. All right, so now we're going to move into actually solving equations. Now, you've actually done a little bit of this throughout our trig unit in chapter 4. This is kind of where algebra merges with trig. You're going to be using a lot of algebra techniques, and we'll apply those as we go. So on this first one, it's pretty basic. You're going to want to get the sine x by itself. So just think back to, if this were my algebra equation, how would I get x by itself? Well, I'd have to subtract 1x over and take my 1 to the other side. The same rules are going to apply here. I'm going to subtract sine x over. That gives me 2 sine x. I'm going to take my 1 to the other side of the equation. I'm going to divide by 2. So tell me the x values, tell me the angles where the sine is negative 1/2. So again, you're going to be going to your unit circle. And we know that sine is negative in the 3rd and 4th quadrants. And so that's where I'm going to be finding my answers. Now, the next question is, should you answer in degrees or radians? And I'm going to tell you to look right here. This is in radians, so my answers need to be in radians. And you should be picking up off your unit circle 7 pi over 6 and 11 pi over 6. Okay, for this next one, we have 3 cotangent squared x minus 1 equals 0. All right. The goal here is to get cotangent by itself, so let's add the 1 over and divide by 3. We remove squaring by taking the square root. Don't forget, and this is very important, you need that plus or minus on your root. So I have 1 over the square root of 3. The square root of 1 is 1. The square root of 3 is the square root of 3. Okay, so we're going to go to our unit circle, and we have 2 places where cotangent is positive, and we have 2 places where cotangent is negative. So we're going to be finding all 4 answers. We're taking 1 trip around our circle. We're staying in radians. So cotangent x is positive at pi over 3. It's also positive in the third quadrant. So 4 pi over 3. It's negative in the second and fourth. And there's all 4 answers. Now, what's typically quoted as your answers here would be your answers in numerical order. But that's not crucial. Now, if you had trouble figuring out cotangent, remember cotangent is, tangent's opposite over adjacent, so tangent is y, let's change that. Tangent theta is y over x when I'm on my unit circle, so cotangent is x over y. So just remember you're taking the x from your ordered pair, dividing it by the y from your ordered pair. Here's another one. We're going to find all solutions again, and here's the interval. So we're going to be in radians, and we're just taking 1 trip around the circle. Okay, it is illegal, and I'll show you why in a little bit, to divide by cosine first. When you divide by cosine first, you're going to be setting up a situation where you're going to lose some answers. I'll share that with you in a little bit. What you want to do in this problem is subtract the cosine over and set it equal to 0. So I want to factor cosine x out, just like that. And then I'm going to set my factors equal to 0. Now, I can do one of 2 things from this point. I can add the 1 over and take the square root, or I can factor it into difference of 2 squares. All right, cosine is 0 at pi over 2 and 3 pi over 2. Cosine is 1 at 0, and it's negative 1 at pi. So I get 4 answers. What would have happened if you would have decided to just divide both sides by cosine? If I divide both sides by cosine, I get cosine squared x equals 1. I get cosine x equals plus or minus 1, and I only get these 2 answers. So if you're not careful, and you don't factor, you're only going to get half your answers in this case. So I recommend that you not solve them this way, that instead you take it and set it equal to 0 and make it a factoring opportunity. All right, example 6, we're going to actually stop here because as you can see, the directions just say to solve, and that has some special things that we need to do. So we're going to stop here for our first video. Let me know if you have any questions.